I'm audible, no, sir? Rahul, sir? I'm audible. Very good. Please.
Hello, welcome everyone, to all the participants. This is Rahul, and I would like to thank all of you for taking your time out and being here over here today. So it gives me a great pleasure to welcome all the participants to a faculty development program on applications of communication, signal processing, and robotics for smart cities, organized by the Department of PCE, Bajbaj Institute of Technology, Kolkata, and sponsored by Atal Academy. So communication, signal processing, and robotics are the three dynamic pillars of modern engineering that are now converging to redefine how we design and manage our cities. To an engineer, communication is not just a data transfer, but the nervous system of an intelligent city. Signal processing becomes the brain extracting insights from countless sensors and devices. And robotics act as the hand enabling automation. But how do we ensure that this flood of urban data is processed securely, transmitted efficiently, and used responsibly? Can we design the cities that are not only smart but also sustainable? If these questions are resonating with you, then today's faculty development program will be an exciting and insightful journey. Time and tide waits for none. So as such, without further ado, I would like to turn myself to the principal of BBIT, Professor Dr. Sandeep Malik, sir, for a keynote address. Over to you, sir.
Thank you, Rahul sir. So good evening to all the participants, faculty members, and organizing team of this faculty development program. So the title is also very interesting, applications of communication, signal processing, and robotics for smart cities. It is really a very nice topic, and I would like to thank first of all for all the participants who have registered themselves for this faculty development program. And I hope that after attending this faculty development program, each and everybody will definitely learn many things about this smart city concept, how it is important nowadays, how you can convert a small city into smart city. So definitely smart city is nowadays very important. So every attendee will definitely learn many concepts related to this. So I would like to congratulate the department for organizing this FDP. And I would like to start from the AICT for giving us this opportunity. And AICT Training and Learning Academy, I would like to thank for believing us in this FDP. And then congratulate our electronics and communication department, or all the organizing committee members, faculty members, HOD madam, and coordinator sir, co-coordinator, and all the members who have contributed to start this faculty development program. And I would like to congratulate all the members who have who have registered themselves, and that they will definitely learn in coming 6 days. So about our institutions, we are affiliated to Macaut, and we have started our institution in 2009, and we are running currently UZ, PG, and diploma courses in affiliated to Macaut and approved by AICT. We are NEC and NBA accredited institutions. Our electronics and communication department is also accredited by NEC. This is the third cycle, continuously third cycle, NB is accredited by this department. So we have around 2000, more than 2,500 students in our campus. We have also lots of facilities available in our institutions, like we have hostel facilities, we have residential facilities for the faculty and staff members, and we have up to the mark all the labs facilities, infrastructure facilities available as far as technical education is concerned. So all the facilities we have there, And this is the first time we are lucky enough to organize this faculty development program in our institution. So definitely this is a great opportunity for us to showcase that we can perform this faculty development program. So all the best to all the participants, and I would like to thank also the uh, the professors who will deliver their lectures in the coming 6 days. I would like to thank them. So they have given their priceless time to us so that our participants can learn many things from them. So thank you so much, all of you, because without your contribution, this type of faculty development can't be possible. So I have seen that peoples from all over India and also out of India, lots of speakers are there in our faculty development program. So I would like to thank them from bottom of my heart, and thank you all of you for this and best of luck for this faculty development program, and all the best to all of you. Thank you. Thank you.
Thank you, sir. Thank you for enlightening us from the breadth of your knowledge and the depth of your expertise. Now, I would like to turn myself to the HOD of Electronic and Communication Engineering Department, BBIT, Kakali Sengupta Das, ma'am, for a welcome address. Over to you.
Thank you, Dr. Rahul Bosu, sir. Good evening to all the distinguished speakers, dignitaries, and audience. I, Kakuli Sengupta Das, HOD of EC BBIT, stand before you with immense joy and gratitude as we gather here for the inauguration ceremony of the 6-day FDP on application of communication, signal processing, and robotics for smart cities. This 6-day FDP is sponsored by AICTE Training and Learning Atal Academy. It will be enriching and insightful journey, and it is my honor to extend a warm welcome to each one of you. Firstly, let me express my sincere thanks to Sri Jagannath Gupta, Chairman of BBIT, for providing the requisite platform to organize the FDP. I am grateful to Professor Dr. Sandeep Malik, Principal, to grace the event with his presence. The Department of EC BBIT is accredited by NBA and NAC, affiliated to MACAUT, and is recognized by UGC. The department is furnished with spacious multimedia classrooms, tutorial rooms, and well-equipped laboratories to assist the significant academic research and development activities. This FDP will broaden the scope of our program and allow us to tap into the vast pool of knowledge and expertise that is brought to the table. I have my heartful thanks to the coordinator, Professor Dr. Deepak Kumar Nayak, and co-coordinator, Dr. Sumanto Bhattacharya, for organizing the FDP. I also offer my sincere gratitude to all the dedicated faculty members who have contributed wholeheartedly to make this program a resounding success. Your enthusiasm and commitment have truly elevated the quality of our academic endeavors. I want to take a moment to express my deepest gratitude to eminent faculties of the Institute of Sustainable Technologies Poland, Zhongshan Institute of Changchun University, China, IIT Jodhpur, NIT Silchar, Alliance University Bangalore, BIT Sindri Dhanbad, and industry expert from Bhabha Atomic Research Center, Department of Atomic Energy, DAE, Government of India. Bangladesh University of Engineering and Technology, Dhaka, VVDN Technologies Private Limited, Haryana, Calibite Private Limited, Intel Corporation, Bengaluru, who have generously agreed to share their expertise and experiences in this FDP. Your insights will enlighten us and inspire a renewed sense of curiosity and passion for our respective fields. To the participants, I applaud your active participation and your dedication to the professional development. In conclusion, let us carry the momentum and knowledge gained from the program into our classrooms, labs, and research endeavors. Once again, thank you everyone for participating in this FDP. Over to you, Rahul sir.
Thank you, ma'am. Thank you for such an enormous and insightful words to us. Now, I'd like to turn myself to the coordinator of BBIT, FDP, Professor Dr. Deepak Kumar Nayak, sir, for a special address. Over to you, sir.
Thank you, Rahul. Am I able? Thank you. Thank you, Rahul sir. Am I audible now?
Yes, sir.
Very good afternoon to all. I am very sorry for last 1 minute something due to issue. I could not connect with you. This 1 week FDP, which is conducted by here, this is the first time we are conducting in our institute, and it is the purpose of this FDP is only one, to enhance the knowledge of the teaching and the capability, the mainly the teaching capability of the faculty member, and energizing the area of technology and research like AI driven research, sustainable technology solutions, and interdisciplinary learning in the area of smart cities and mobility. Over the next 6 days, we'll be hearing from eminent national and international experts from academic and industry who will use their experience, who will give their experience with the best practices. As the coordinator of this program, it has been a marvelous journey to bring together so many research persons and enthusiastic persons, in intelligent participants from all over the country. I sincerely thank AICT and the Atal Academy for providing this excellent platform to educate across the nation, enabling us to stay updated and innovative in way of teaching and research. My heartfelt gratitude to everyone for joining us today, and to our chairman sir, all management and principal professor Sandeep Malik sir, all the deans, HOD Department of EC, Calculation Das, and all our faculty members for their constant support. To all the participants, I encourage them, I request them to attend all the days and interact with the speakers, who are almost 50% are from the international. So interact with them, make the session live, so that we all will be benefited. Once again, I welcome to all for this FDP for the grand success of this. Thank you all. Over to you, Raj.
Thank you, sir. Thank you for such engaging and encouraging words. So before we start the session, so a little housekeeping before we get started. So if the audience have any kind of questions during the session, please type them into the chat box. They will be brought up right after the presentation and we will have time for the questions at the end. And if you miss anything, don't worry. We will be sending out the on-demand recording when it's available. So right now, the session one topic is hydrogen technologies as the foundational economic decarbonization for smart cities application. And the expert who would be delivering the lecture on it is Dr. Martha Jurek-Motka. So Dr. Martha is the director of Mechatronics and Prototyping Center, Recovery Research Network Institution for Sustainable Technologies. So before, let's have a brief introduction to Dr. Motka before we start the session. So Dr. Motka is currently working as the Director of Mechatronics and Prototyping Center, Recovery Research Network Institute for Sustainable Technologies. So previously, he was a senior researcher who had worked in the Recovery Research Network Institute for Sustainable Technologies in Braden in the Department of Control Systems since 2021. She obtained a PhD at the Faculty of Transport, Electrical Engineering and Computer Science at the University of Technology and Humanitarian Kazimierz Pulaski in Braden in the field of electrical engineering in 2020. She was an Erasmus PhD student at the Faculty of Electrical Engineering at the University of Ljubljana in Slovenia in 2019 to 20. She has also been a lecturer at the Sput University of Applied Sciences since 2023. She is a member in the Polish Association of the Electrical Engineers and a member of the expert team of the European Commission and the National Center of Research and Development in Poland. She is also a member of the organizing committee of international conference mainly organized in Asia, as well as a keynote speaker from the STEM area. Her scientific interests include, among others, electromobility, renewable energy, powered electronic converter for electromobility and renewable energy sources, sustainable technologies and development, waste heat conversion, and hydrogen technology. At present, she collaborates at an innovative solution related to modular hydrogen production and storage systems, waste heat conversion, and industrial scenarios of renewable energy-based electromobility. She is an author and co-author of over 30 publications in Scopus, Web of Science, and IEEE index journals and databases, as well as a co-author of 5 patent applications. So she has a teaching qualifications and has a function as a supervisor student internship from Poland and India, and conducts training in the field of electromobility and electrical engineering. So with this, I would like to invite the speaker to enlighten us with her lecture.
Good afternoon. Can you hear me good?
Yeah, ma'am.
Thank you so much. Thank you for interaction about some words about me. So thank you so much for this short introduction. Today, I would like you to share my experience and views about the hydrogen technologies, especially in the project that I do some research now, because now I am out of my office and because I do internship in the University of Zagreb in Croatia. So sorry for any interruptions and troubles with connections. Sometimes there are. And I don't switch on of my camera because of the unstable connection. So I will share my screen. Just a minute. Just let me know it is visible.
Yeah, ma'am.
That's okay. All right, so let's go next. Okay. Mhm. All right, so today I would like to say some words about especially about my institute, where I work every day, what I'm doing, what about my department center, and then I will talk about the hydrogen in the research, what is necessary for this, the key role in green new economy, and then I will show you our project that the main issue is related with the water preparation system for electrolysis as well as power electronics, because we know that we have to obtain the green hydrogen, not any others from fossil fuels, but the green. Green, that means it is from renewable energy sources. So there are some problems with the connection, and I would like to show you some different ways, approaches, how to do it and on time. And also this is also a reason that I'm here in the University of Zagreb, because here I'm the laboratory of hydrogen technologies, and we do some research about the power integration with hydrogen components. I mean, for example, compressor, electrolyzer, hydrogen storage with the power electronics and renewables. And then I will show you also another project which is close, that can be used in this, the first one. It is related to waste heat recovery system that can be used in the hydrogen installation. Okay, so let's go next. So some about my institute. And Łukasiewicz Research Network, because my institute belongs to this, I can say that is a third largest network, but the youngest one in the Europe. We have 22 research institutes located in 12 cities in Poland. And nowadays it could be more than 1,500 projects in progress. And we have also 440 research laboratories and more than approximately 4,000 devices of key research operators. And now, and the scientific staff, approximately 4,500 scientific and engineers involved in different projects in these 22 research institutions. Okay, and I can say that nowadays our strategy of Łukasiewicz Research Network focus on mostly of these four areas related especially to chemistry for industry, circular economy, energy transformation, and defense industry. My institute mostly focusing on energy transformation and circular economy, and other areas are also important for us, but we do, how to say, in less projects in these areas. So let's go next about my institute especially. So next year it will be 40 years celebration of my institution, and it has been specializing in building up innovation performance in the areas of machine construction, maintenance, technical and environmental safety. And additional areas of institute activity include model solution in the field of technology transfer and continuing vocational education. So in my institute, they are employing approximately 200 engineers and scientists. And we cooperate with different institutions, foreign institutions, for example, in centers, for example, from Finland, Germany, France, Italy, Denmark, or Mexico, and also any other with different projects that are funded by European Commission or another. We also collaborate with the industry, especially in the commercial project that we do some test apparatus or technological lines for different industrial branches. And here are a division of my institution, the prototyping, and nowadays it is Mechatronics and Prototyping Center from this year. The second one is Bioeconomy Innovation Center. Next, Surface Engineering, Center for Vocational Education, Innovation Management, and Tribology Center. And we have also the Scientific Publishing Department. I work here in the Mechatronics and Prototyping Center. That is also divided for 4 departments like prototype structures and architectures, optomechatronics, prototype manufacturing, and control systems. I'm from this department. Okay, briefly about the another department that I'm focusing, for example, Surface Engineering Center is focusing for designing, dedicating the coating material solution and technologies for the development of specific areas of application. This center is focusing mostly on surface treatment technologies, POID coating materials, and any other what is related with that. Tribology Center, they analyze friction, wear, lubrication, machine parts, and tool components with particular focus on research method and devices. And for example, my center, Mechatronics Prototyping, we closely cooperate with Tribology Center because we make this type of devices in test apparatus for different tribology, for methods and analyzing of different research related with that. Unfortunately, I can't explain you more about it because the tribology is not my area of research, but I can say that we do, for example, such like that test apparatus in tribology activities and research methods that can analyze the surface, for example, imaging, elemental phase, stereometric, or analyze the friction work processes, and any other data related with that. It's possible to buy, for example, this type of machine. It is based on your, if you have this type of research or needs in your institutions. And we approximately have 40 different test apparatus. Okay, let's go next to the Bioeconomy Innovation Center. And they focus on new methods and research instruments aimed to increase durability through new materials and industrial waste bioconversion. We also collaborate closely with this center because in the hydrogen installation, we have the water preparation system that is really important for us because it is the water is proceed by multi-steps conversion, treatment to supply the electrolytes. It is important really for us because this water should have the proper indicators that can be used for supplying the membrane electrolyzers. Okay, the next is our Mechatronics Prototyping Center. So that I said, we focus on new devices that increase in durability of technological objects, expanding the service life. For example, we can make different test apparatus or technological rights, or also for industry that can be used for different, also for research purposes, like analysis of resistance or environmental factors. Or we have also AMC laboratory to do on research of electronic devices and others. Okay. Next, there are some examples that I was made in my department of control systems, as you see here. Okay, and Center for Vocational Education, Research, Innovation Management, they focus on the work pedagogy, job competence, says profiles, and they do research on develop and implementation and dissemination activities for vocational education, andragogy as well education, career counseling, everything what is related with education. Okay, and now I can tell you more about the hydrogen in the industry, what is the purposes to use it, and main goals. Here you see the picture that I was in last year in November in EU Hydrogen Week that took place in Brussels, in Belgium. It was a big hydrogen fairs. And here I can meet some people from industry or research institutions, also from government, that are interested in hydrogen, how to use it, and companies provide them to different attractive solutions, for example, based on them. Hydrogen technologies, element components that can be used for example, in transport, in the residual areas, and other related also with the safety. Okay, so while we are talking about this hydrogen, why it is important really for us? Because it can play an important role in helping her to abate sectors that meet climate targets. So countries with hydrocarbon resources and industry expertise can help build and scale the needed technology. So by 2050, clean hydrogen could have abated even gigatons of carbon dioxide emission annually, which is about 20% of human-driven emissions if the world remains on its current global warming trajectory. So complementing other technologies such as renewables and biofuels, hydrogen has the potential to decarbonize a variety of sectors. For example, industry, I mean the steel making, ammonia synthesis or fertilizer production, long-range mobility as a fuel for heavy-duty trucks, maritime, shipping and aviation to produce synthetic fuels for vessels and building heating. Hydrogen can also be used for flexible, long-term storage for power grids. Industry and transportation account for most of hydrogen abatement potential, which has a cumulative emissions reduction upside of 80 gigatons of carbon dioxide through 2050. So more than 680 large-scale hydrogen projects have been announced globally, amounting to $240 billion in direct investments. So the projects include giga-scale production, large-scale industrial usage, transport, infrastructure, everything related with that. So in Europe, which accounts for, how to say, let's say half of this project, announced projects. Hydrogen is expected to play a significant role in meeting the decarbonization targets with usage across industrial application, transportation, and power generation. So clean hydrogen is expected to play a critical role in decarbonizing typically hard-to-abate sectors such heavy industries, long-haul transport. However, significant challenges must be resolved, and the hydrogen value chain is both complex and capital intensive. Many segments are not yet developing at the same rate, and staying abreast of constantly evolving technologies and regulation can be dynamic. And numerous recent publications illustrate that increasing attention around this topic. Why? Because it is also safe. Environment friendly and high efficiency. And of course, the most important is the regulation, the legacy of that. So today, most hydrogen is gray, especially in Poland. Which means it comes from hydrocarbons, typically natural gas. This requires a process known as steam reforming, which releases carbon emissions. Blue hydrogen, for example, also release hydrocarbon, but is coupled for carbon capture, utilization, and storage technology, which helps mitigate the environmental impact, but can require incremental waste investments. Finally, green hydrogen is created using renewable energy, typically through the electrolysis of water, and results is no emissions. That is very important for us. To generate the green hydrogen using the renewables, and then to supply at the end of, for example, we can do to the electricity grid or refueling station to supply the transport means. And here you see the global hydrogen economy, what is nowadays in the different countries and their perspective of use it in the next decades, I mean. For example, in EU, it's most important that it can be 10 million of metric tons clean hydrogen can be produced and imported by 2030. Within a few next years, it is possible? Probably yes, in most of countries, because here we have different opportunities of common projects. And for example, a few months ago, one call for hydrogen projects was announced and ended, related to how to build a different installation, the hydrogen hubs, and the connection, like for example, in the same way, like using gas, it can be possible to make dates. And for example, you see the India, your country, it is announced that it can be 5 million metric tons of green hydrogen produced in a year by 2030. This is also very important. Why? Because I showed you that there are key recommendations for hydrogen can be included here. Like, for example, in the increasing of hydrogen production. So this report, Draghi report, calls for increasing investment in green hydrogen production, notably through electrolysis using renewable energy sources. And the next step of key recommendation is to develop the infrastructure. That is very important also. And most of the projects are based on it. So establishing a solid hydrogen infrastructure is highlighted as a priority. And this includes building pipelines, storage facilities, and cross-border network to facilitate hydrogen trade within and outside Europe. And the aim is to ensure that hydrogen can be widely used in various sectors, such as transport, energy, and industry. The next is most important, the regulatory and financial support. As I said to you, that there are more it's opportunities of common projects with different countries or abroad, not only in Europe. And in this report, they highlighted the need for favorable regulatory framework and financial incentive incentives to boost hydrogen innovation and adoption. It also suggests simplifying permitting processes and creating clearer standards. Okay. And what next? The collaboration and innovation. That is also important to collaborate with different countries, not only in European and also on abroad. Okay, and so in a world-bound the grip of fossil fuels, for example, India has taken steps forward at different proposals to toward different parts. So with a boat of net zero targets set for 2070, the nation is reimagining its approach to energy. As noted by the Asian Development Bank in its recent Asia Pacific climate report, India is shifting its focus from an unsustainable dependence on fossil fuel subsidies to fostering clean energy. So guided by a remove, target and shift strategy, India steadily whittling down its fossil fuel support, opening doors to new investments in solar power, electric vehicles, and a stronger energy grid. So it also results in reforming fuel subsidies, has proven transformative, slashing subsidies by striking margin between 2014 and 18. Okay, let's go next. So we can observe it. Here you see some pictures that I took on the hydrogen week. There are some examples. What for now this hydrogen powered heavy duty vehicle can be supported by and can be powered by hydrogen, and like electric vehicles. So I can say that fuel cell electric vehicles use electricity to power an electric motor. So here is also the, I'm not sure this is what or not it, because this is on this picture you see the example of the fuel cell supported electric vehicle that can be implemented, that is implemented in, for example, Toyota Mirai. So in contrast to other electric vehicles, fuel cell electric vehicles produce the electricity using this fuel cell powered by hydrogen, and rather than driving electricity from only the battery. That is the main important difference. So during the vehicle design process, the vehicle manufacturer defines the power on a vehicle by the size of electric motors that receive electric power from the appropriately sized fuel cell and battery combination. And automakers who design fuel cell electric vehicle with plug-in capabilities to charge the battery. Most fuel cell electric vehicles today use the battery for recapturing braking energy, providing extra power during short acceleration events, and to smooth out power delivered from the fuel cell with the option to either turn off the fuel cell during low power needs. And the amount of energy stored on board is determined by the size of hydrogen fuel tank, as you see here in this picture. So this is different from all electric vehicle, where the amount of power and energy available are both closely related to the battery size. So various methods are available for the storage hydrogen. For example, compressed storage and cryogenic liquid storage of hydrogen, or the most commonly used in industry. Compressed hydrogen storage can take place in steel containers or containers made from composite material, as you see here. They are used, for example, for truck transport, vehicles, and hydrogen storage in industry, or at hydrogen filling stations. So the pressure level here is between 20 and 80 bar. To store hydrogen in vehicles, the automotive industry relies on the use of pressure tanks, where the pressure level is up to 70 bar. This means that fuel cell vehicles have similar range to petrol cars. In addition, it is generally possible to store hydrogen under extremely low overpressure in gasometers. For example, 0.002 bar. Okay, this is description of our project that we make the system for water preparation, for electrolyzer, and storing hydrogen in this type of installation. And the aim of this project is to develop a water preparation system of appropriate quality intended to power the electrolyzer and hydrogen storage system. So the primary source here will be water recovered from in a hydrogen fuel cell, but it can also be a top water, a wastewater, a various composition, especially in the case of hydrogen storage installation with generating electricity. So it is assumed that a multi-stage water purification system will be built, in which each module will be responsible for the removal of individual pollutants. I will show you in the next slide what this installation can look like. So concept for the energy part, the laboratory hydrogen installation will be developed, including the following systems such as receiving hydrogen from electrolyzer, compressing, storing hydrogen, and generating electricity using fuel cell. And you see this type of hydrogen, conceptual hydrogen walling here. Because we do this research in collaboration with other institutions from Kashich Research Network that are focusing on different parts. We mostly focus on this system and how to supply the electrolyzing using renewable energy sources. For example, solar or wind turbine and energy storage mixing with this combination. And it can be bidirectional, in bidirectional usage. For example, we can generate and electricity and give it to the power grid. And also additional systems such as there are oxygen storage or distribution systems. And what it can be at the end, it can be, for example, hydrogen fueling stations, or it can be go to directly to industrial systems, for example, for supplying, like for heating reasons or processing purposes if it's necessary. And here you see the conception of hydrogen hub. Well, again, can be named in different ways. That is powered by renewables, as you see here, the conception, using wind turbines, wind farm, solar farm, battery storage. It is elaborated from Bosch company. And then it is simplified. And then the hydrogen is processed in this here in storage in tanks. This is hydrogen grid and trailer, and then supplying for different parts of industrial economy. This is only an example. These types of system can be really different and can use it in different ways, not only in this, such as you see here. It's only an example that I took a photo during the Hydrogen Week in Brussels. And what is important, now I do some research, for example, how to supply, how to connecting using different power electronics and versions. and supply the electrolyte for electrolyzing processes, for example, in urban areas, and how to make it also digital twin and manage it in, for example, in industrial systems. Okay, let's go to the next slide related with the particular systems. Here I will talk about the water preparation system for electrolyzer supply. So I can say that one strategy that electrolyzer manufacturer can follow to simplify the issue is to set the requirements for conductivity sufficiently low to ensure that the concentration levels of problematic ions and molecules will in all certainty be below the electrolyzer requirements. That is very important to use the proper with proper indicators the ionizer water for electrolyzer supply. So a good starting point can be below the 1 microsiemens per centimeter for standard alkaline electrolyzers and below 0.1 microsiemens per centimeter for membrane electrolyzers, I mean the PEM electrolyzers that rely on advanced electrolysis. However, it is worthwhile to remember two things. Firstly, water treatment constitutes a relatively minor part of the total capex of hydrogen plant. And secondly, no electrolyzer was over-damaged by using water that was clean. Ensuring high quality and reliability in the water treatment might too be the best investment to make for an electrolyzer system. And we can accurately calculate the amount of ultra-capture water required for production of green hydrogen using the atomic composition of water. Since oxygen is 60 times heavier than hydrogen, it is responsible for 89% of the mass of water, which means that 9 liters of water is needed to produce 1 kilogram of hydrogen. This ratio can be quite useful to determine the water requirements for a specific production capacity of hydrogen. And for instance, production of 100,000 tons of green hydrogen per year will consume 900,000 tons of ultra-capture water. And here you see the different parts that is combining of the system. Here you see the elaborated part of the installation in our department. This is the integrated system for purification technological liquids using membrane techniques. This is this part of this part. Installation, and then we see the small installation of hydrogen. Here is the electrolyzer, storage tank, and only in this part because it is still in building. So the next time maybe I can show you the whole installation that is working. So let's go to the second part. Focus on this, drying, compressing, drying, and hydrogen in this type of systems. What is the most important? So the water circulation system in this type of installation. The role of the pretreatment system is to make the raw water sustainable for a feed source for the pollution system. So this means bringing the water to a state where it resembles city water quality. And the type of treatment system depends on the source of water. And here you saw the really complex, but it can be more than complex. And groundwater, for example, contains dissolved radioactive species, such as iron or manganese, which can precipitate in a clogged the pollution system. This can be effectively removed using aeration and sand filtration. For treated wastewater, the primary concern are particles, organic and microorganisms. Here, ultrafiltration in combination of this ultrafiltration can be used to bring the water to a sustainable quality. Seawater primarily requires removal of salts, but also of particles and dormant microorganisms. So using standardized reverse osmosis, desalination is sufficient in this type of process. Once the raw water has been treated, we need to address the following issues to turn into the ultra capture quality, such as content of ions, that means the conductivity, hardness, TOC, silica traces. So this is our example that is in our laboratory, and then how to use it, the water in this system. But let's focus on another issue related with renewable to supply the power, to supply the electrolysis process. So here there are also different problems and opportunities that we can use if we consider only the one source. For example, here, if we look only for the grid powered systems, there's more than problems than opportunities. For example, we have to obtain green hydrogen, not fossil fuel, not any other. So it is a conventional energy. Despite of this instability and can be future to nuclear energy, but there are some problems with connection, interaction, and resistance to the grids. The another issue related that we have to focus on this type, only this type of source. It is in the problems are related with instability and needs for additional power supply, for example, combining with energy storage. And of course, this is our renewable energy, such like this and this. And the most important is to fix it, combining it in the one part, and how to manage this energy for supplying the electrolysis processes. And it also needs for proper conversion, this type of energy. And here we use this DC converter. We use it because of its modularity, energy conversion efficiency, isolation control, and but there are some limitations and lowness. But another also solution is to use the direct connection of, for example, solar energy supplying the electrolysis processor. But here are more problems than opportunities. And for example, instability, lack of production predictability, or intermediate operation of the electrolyzer. But don't need some unnecessary conversion like AC-DC or DC to AC. This is a simple solution, and later I will show you the purposes of use it. This is a table about the comparison the electrolyzer power system topology that can be used. Nowadays, the most is used the AC single stage power system, supplying for mostly for alkaline electrolysis. And you see it is as a product, using it as a product, not concept, but it's still changing. And with quite good efficiency. Also, you see the power of megawatts. But we consider the DC, for example, single surge or isolated single surge or interleaved parallel or master slave or three-fourths that can be, most of them are prototypes with small power. And for example, we have to consider that we have to use it in membrane electrolyzers. but we have to obtain more than 90% of efficiency that can be similar to this one. Nowadays, that is a bit lower, but it's still changing because of using different components of parts that are better than before. Okay, the other issue is related with powering the processes. Here I used, I modeled it, how to use the boost converter to supplying the electrolyzing processes using with PWM modulation. And here you see that it's possible to update the constant parameters, I mean the current and voltage. And this is only an example that I'm still doing research on that and mixes, because the most important is how to manage this energy and obtain the stable parameters at the end. And using a control system with DC-AC converter using the PWM sinusoidal modulation, it is well known almost everywhere. And here you see at the end, as I said before, it is possible to obtain the stable parameter of voltage, approximately 6 volts. Here is 600 volts. I can read. So I can tell you about another issue that I said before, noticed before, that it is possible to connect the indirect the solar plants, for example, with for electrolysis processes without any conversion, unnecessary conversions. For example, even here, this is one interesting solutions that can be made by one university. Sorry. This is one solution developed by researchers at the University of Leuven in Belgium. And this technology is now being run by a startup called Solheid. And here you see that it's using directly the solar panel that is connected directly to the hydrogen stack, and the water is obtained from the air. And you can, but what is the problem with this type of solution? That everything is related where it can be used. That we know that in Europe there are not too much the sun, and the producing of sun is not so much than in other regions in Europe, in the world. So it can be used, for example, this solution can be used in Asia, in Africa regions that is still have almost all years still sun. And more about it you can find on the website, how it's worked, how it's produced. This is a very interesting solution that don't need any conversion of this type of energy, but unfortunately, with some obstacles to use it because of this nature. So I can say about the waste heat recovery systems, how can we use it in hydrogen installation? Why it is also very important. We have another project related to it because for example, from the electrolysis process, there are some produces the heat from this type of processes. And here we have another project, but we use the thermoelectric generators. And we want to obtain the maximum value of electric current power from the heat flux under the conditions of energy balance in the system, and provide high temperature heat energy to the hot side of thermoelectric generators. I will show you how it's working in the next slide. And we take into account the compensation of uneven temperature distribution of the surface of the waste heat source and maintain the nominal operating temperature of thermoelectric generators. And in here, in this installation, it will be enabled the conversion of DC output waveforms of thermoelectric generators into power grid parameters with the possibility of working as on-grid or off-grid systems, and of course ensure that the operating point is maintained at the maximum power of thermoelectric generators. So heat collection from the cold side of thermal generators must be effective and ensure minimal energy consumption. That is the main reason of using. And most important is control system that monitors the condition parameters of the system and enables cooperation with external other systems, such as hydrogen installation. Our experience with this type of system sets shows that main problem of this type of installation is the reception energy from the cold side of thermoelectric generators due to its nature, and because we need also find a proper source of cold side. So in this case, sometimes we have to use an absorption chiller or an other that can support this type of system, because the most important is the temperature difference between the cold and hot side of chiller. And here you see how it works. And the goal is to develop a multivariant system for waste heat recovery in industrial conditions to obtain the big difference between the hot side of heat exchanger and cold side. It can be approximately for 1 kilowatts, the temperature difference approximately 60, 70 degrees. And the most important is to develop a series of thermoelectric generators that allow the system to be adapted to user existing conditions. Not only a particular type of system, but also for another one. It must be flexible. And it can be implemented in different type of system, for example, industrial processes, electrolysis, not only, it can be in metallurgical process. And here you see the view, what is inside of the heat exchanger, the main. This is our project, this is our concept of, because here, and as you see the rows, there's the circulation of the water. We use the water like a medium of to exchange the heat between the cold and hot side of the plate here, and we did some research that this construction is the most effective to use it. And then we elaborate a proper converter with the control system that take operating point is most effective. And then we convert this using this DC converter to electricity parameters. So here you see the most pictures about how it is. For experimental tests, we use the thermoelectric generators available on the market, but we do one of institutes involved in this project elaborates another type of thermoelectric generators with better PN parameters of thermoelectric cell, with power more than 300 watts. So this type of thermoelectric modules are used to directly convert thermal energy into electricity. So their construction does not require any moving parts or working fluids. They start up immediately and they work in any position, don't need any spare parts or maintenance. And of course, they have long service life, 20, 30 years can they work. And they work in a wide temperature range. That is very important for us. As you see, from minus 55 degrees to 83 in different So what else? So it has been proved that the supply of high thermal energy to the thermoelectric generators results in a higher conversion efficiency and the amount of required electricity. And the technological process and lower prices mean that it's economically and technically justified to use them for generating electricity, even from low temperature heat. Low temperature, I mean, for example, approximately 100 degrees Celsius. So this is, I can say that this is a semiconductor element and that can operate in two ways. Convert thermal energy into electrical energy. It is called Seebeck effect, or convert electrical energy into thermal energy. It is a Peltier effect, but we use the first one with Seebeck effect. And transition from the state to another and vice versa take place smoothly. And it is necessary to analyze the mutual influence of this type of thermoelectric generators on the ability to generate resultant power with serial or parallel connection depending on the temperature distribution and heat supplied. So this purposes, two groups or more, here you see also the four groups, connected in series were created, as you see here. And the view on the heat exchanger with noticing the temperature in different parts, measured in different parts. And see there are only 1 degree approximately difference here. The most hottest is on the middle of this heat exchanger. And here is at the research station that has modular structure, enabled rapid modification of water development through the use of various low temperature heat sources, different cooling systems, and thermoelectric generators. Why I see that we use the big tanks? It is only indicates that it's a cold source, this is hot source, only it's reflective. Only reflects that the two types of sources that is needed for these conceptions. Okay, so let's go next. And what this looks like here in our laboratory. So this pictures presents schema and the construction of research station with a storage tank that reflects the high and low temperature parameters as a cylindrical tanks, as I said before. And what else? So what is the most important? That the coils forbid direct contacts of liquids in the exchangers here, and has the possibility of using liquids with different freezing evaporation temperatures is also possible. So consequently, it can be used to extract heat from sources with different temperatures. So the maximum temperature of heating the liquid in the tank is set approximately 95 degrees of Celsius for water which stores heat energy, while the minimum temperature for cooling liquid is 4 degrees of Celsius. It is only a laboratory standard, and that proves that this type of system can work properly. So what's next? So the storage heat exchange modules with low thermal parameters are adopted to cooperate with different heat collection systems. So an example of which a dry of wet cooling tower or fanless cooling tower absorbed aggregate. So tests confirm that the correctness of operation of the system and ability to generate electricity as a result of temperature difference between the covers of the thermoelectric generators. This is confirmed. That is what. Research station can be used to verify operation of low power systems that use small number of thermoelectric cells in which the output product is only direct current. And It also enables the conversion of thermal energy from waste heat source with unstable parameters to thermal energy with utility parameters. And this station presenter can be used to dissipate thermal energy in the module of this here facility. I mean the storage module with low thermal parameters during natural farm temperature at night, and significant reduction in electricity consumption may be achieved here. So more about it you can find the journal machine construction and in the energies how we did it related with this type of system. Okay, to sum up at the end of my lecture, I can say that it is necessary in hydrogen power installations from available powered by an available energy source that is necessary to use DC-DC converter that match the voltage of this energy storage to power supply parameters of the electrolyzer. And the most important and the challenge is to build a power supply that meets the requirements of dedicated industrial power supply, low cost, high energy, and high reliability. In waste heat recovery system, I can say that is our original solution to recover the energy from electrolysis processes and use for all needs. And I mean the circular economy, it is provided, it is a proof of that. But the problem is the recovery of waste heat and its conversion into electricity. It's still a problem due to the efficiency of thermoelectric generators. It is still low, approximately 5%, but the works are still going on that it can be more than 5%, approximately 10% of efficiency. Okay, so thank you very much for your attention. That's all for this related to hydrogen technology, and we connected with waste heat recovery system from electrolyzing process because we still do this type of research, and I think that the next year I will finish it and can show you more, especially in the one part related to renewables, how to power it and manage this energy to supply continuously the electrolysis process. That is very important for us to combine it, fix the solutions, fix the problems, and to find proper solutions with power integration. And maybe in the future it will be possible to present this as a digital twin of renewable energy power supply of this type of system. So that's all for this. If you have any questions, you can ask me now or later contact me by LinkedIn, for example, or by email. As you see here in the below, this is my email. Thank you so much.
Thank you, madam. Madam, I am Deepak sir only. I have contacted you, no? Hello?
Yes, yes.
Yes, I am Deepak sir only. I had a contact. Actually, due to some issue, technical issue, I could not talk to starting time, madam.
Yeah.
If anyone has any questions, please ask to madam.
Yeah, if you have, that would be good. If you don't have, it's also good. So you can
Yes,
try to contact me later.
yes.
I understand because it is a hard topic.
Yes, madam.
Overall
It's
general information, but then I think that after my research, I can say I can show you more about the power integration with this type of system because it's still not solved projects. There are different projects related to it, but not as a commercial projects, only in a lab stand. But it's still changing. It may be in the close few years, it will be the solution can be implemented in different type of industrial companies and also residual areas. I hope.
yes. Anyone want to ask anything? Otherwise, we will go to second session. Okay, madam. Thank you very much, madam. You have taken one long lecture actually.
Thank you so
Actually,
much.
this is the third time you have come here, madam.
Thank
Thank you, thank you,
you
thank you
so
very
much.
much, madam. I'll contact madam. One small request. We
Yeah.
need five actually MCQ type multiple choice questions. Only 4 to 5 we need. Kindly will send it through my that mail ID. MCQ, that means multiple choice questions. One question will be there. There will be A, B, C, D like this. 4 choice will be there. We need
Um,
4 to 5 questions. Did you understand, madam?
Once again, because
We
there are
need
some.
question. No, no. We want to float it to our them. That means what they have understood. It must be measured. So that we request you to give 4 to 5 questions only, madam. For
Mhm.
example, this is this A, B. Got idea, no, madam?
Yes, I hear you.
Yes. Someone only 4 to 5 okay.
Please, once again,
Up, madam.
interruption in connection, poor connection.
In connection to this subject only. Whatever topic you have taken related to this, we need 5 questions, madam. Small questions only. 1 mark like type questions. Because
Mhm.
we have to last day we have to take one test
Uh-huh.
out of, because we have how many expert lectures there. From every lecture we will collect around 4 to 5 questions, and it is should be circulated to the all the participants. Got
Okay.
idea, madam?
All right. I
Okay,
will
just
prepare.
only 4 to 5. Oh
No
yes, you
problem.
prepare and send me just a 4 question and also answers A, B, C, D, which is the
Mhm.
correct answer. That
All
will
right.
flow after last day. It's need, no need now. Anyway, madam, I will contact with you after that. All related issue, I will get back to you. You kindly send it within 2 3 days. No issue. Our program last will be on the 18th, madam. Last day we will do it actually. Last day. You have to make it. Thank you very much, madam.
Thank you so
You can
much.
another question. Okay. Okay, ma'am.
Yes, it was a
Thank
pleasure to share my experience and views about it. So thank you for your attention. And about
yes.
these questions, I will prepare you. But
Yes,
first,
yes.
send me a message about it, and then I
Yes,
will.
yes, 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 madam. In WhatsApp also I will send exactly. Otherwise, one
Got
pattern I will send, you can understand.
All right, no
Yeah.
problem. I will prepare.
Okay. Okay.
So thank you.
Thank you, madam. I will get it. Okay.
Okay, so thank you so much
Okay.
again, and see
Okay,
you
okay,
next
madam.
time, maybe personally in the
Yes, yes.
university.
Sure, sure, madam. Sure. Thank you.
Bye.
So, bye. See, our second session will start after 2 minutes. Sir, have you joined here, sir, already? Anshuman, sir, are you there? No, sir. Hello, after 10 minutes, we will, dear all, after 10 minutes, our second session will start. Please all be there. Please all be there. After 10 to 15 minutes, it will start. 10 minutes. Yes, sir. After 10 to 15 minutes also, you can join. Not an issue.
সেটাই আমি
Okay, sir.
सर आए हेलो अंशुमन सर
Hello,
हेलो गुड आफ्टरनून सर
good evening.
हाँ गुड इवनिंग केम ना ओके सर
Good evening, Anshuman sir.
Good evening. How are you, ma'am?
Fine, fine.
How are you, sir?
फाइन सर
Hello, Suman sir. Good evening.
Good evening. How are you?
I am okay. Thank you for coming here.
Good evening to all the participants. Welcome to the session 2 of the Faculty Development Program on Application of Communication Signal Processing Robotics for Smart Cities. And now for the session 2, the topic of the lecture is Deep Learning for Medical Image Analysis. And today's technical expert is Dr. Anshuman Paul. So before we invite him to commence his lecture, we would like to have a small bio sketch. So Dr. Anshuman Paul has completed PhD in 2019 from Indian Statistical Institute, Kolkata, India. He has completed ME in the year 2012 from Jadavpur University, Kolkata, India. And he has also completed Bachelor in Engineering in the year 2010 from Jadavpur University. Currently, he is working as an assistant professor at the Department of Computer Science and Engineering in IIT Jodhpur. His previous positions are postdoctoral fellow from National Institute of Health, Bethesda, USA. He has been a visiting scientist in the Indian Statistical Institute in Kolkata, India. His research interests include medical image analysis, machine learning, computer vision, to name a few. So he is working on a funded project research related to machine learning for medical image analysis. He has published many international journals with Age Index 8 and citation with 300. With this, I would request Anshuman sir to start his lecture. Over to you, sir.
Thank you so much for the introduction, Mr. Bosu. It's always a pleasure to be part of this FDP. If I remember correctly, in the last year also, I had the opportunity to present a talk here. Without further ado, let me start. And for the sake of bandwidth, I'll turn my camera off. In case you have any difficulty in hearing me, please feel free to let me know so that I can look into it. Let me share my screen first. Sure. Just give me a second. Is my screen visible?
Yes, sir. Yes, sir. Visible.
And you can see it in the full screen mode, right?
Yes, sir. Full screen.
Okay, thank you.
Okay.
So the title of that talk today, although I had initially planned deep learning for medical image analysis, I have slightly changed the title of the talk as deep learning and its applications in medical image analysis. So I thought that why don't I present a brief introduction to deep learning at the initial part of the talk and then show you some applications in medical image analysis as well as for medical image synthesis part, because as we all know, generative models are becoming very, very popular these days. So I'll show you some applications of generative models with some of our recent publications in that domain with deep learning approaches. So I'll start with the very basics. And I'm requesting all the participants to interrupt me anytime. If you have any questions, please feel free to stop me and ask the questions. So before I go into the talk, usually I show the books and the other study materials which have been helpful for myself in preparing these lectures. I also teach deep learning in IIT Jodhpur. So some of these materials have been very, very helpful for me for my preparation. I believe these materials will be helpful if you want to get into the depth of deep learning. So before we get into the details of deep learning, we first have to understand why we are talking about deep learning these days with so much of emphasis. First of all, deep learning is arguably the most successful machine learning approach. And as you might be aware, that machine learning is not a new field. It is there for almost 60 years at least. But it's actually more than that, 70, 75 years. But prominently 60 years, there is different machine learning approaches have been proposed. However, with the advent of deep learning, the domain of machine learning saw tremendous success in last 10, 12 years. So there is no doubt that it is one of the most successful machine learning approaches, which can be used for supervised learning, unsupervised or weakly supervised learning, as well as for reinforcement. Acha, I'm having slight feedback. I think some microphone is on. If it can be switched off, that would be extremely helpful. All right. So, as I said, deep learning is one of the most successful machine learning approaches, which is useful not only for supervised learning, but also for unsupervised or weakly supervised learning and reinforcement learning, the three prominent pillars of machine learning. And deep learning techniques have been very, very useful across different types of data, including attribute-based data, for which we have deep, fully connected neural networks, for images, for which we have CNN models, vision transformer, etc., etc., for audio, video, and many other sequence data for which we have RNN, LSTM, GRU, and many type of transformers to handle this kind of data. So, in a sense, deep learning techniques are diverse in nature. Many, many different types of deep learning approaches are available. Whichever data you want to process with deep learning methods, you are most probably going to find an absolutely suitable deep learning method for processing those kind of data. This is one of the reasons for success. So as you can see in this screen, this is one of the first hardware implemented neural network, which is known as Mark I perceptron, built by this person, Rosenblatt, right? And when he proposed, this is ironically when he proposed to design these models and he built this model, it did not show much success. And his contemporary researchers were doubtful about the applicability of these methods. But long back, more than 70 years back, people tried to design deep learning methods using this kind of hardware structure. And I guess some of you can identify this person on the left. Can anybody tell me who is this person? Uh, Anyone interested to let me know? So, if you don't know, this person is the famous Geoffrey Hinton, who won the Nobel Prize in Physics last year. And this is a picture when Geoffrey Hinton's proposals about deep learning were not accepted by the machine learning community. People thought that probably this type of methods are not going to be very much beneficial. In fact, he often says that for a good 20, 30 years, deep learning did not show any kind of success. But after that, when it came with a bang. So this person, alongside Geoffrey Hinton and this person also, John Hoffield, he was also responsible in the development of deep learning methods. And it has been so successful over last 10, 15 years that the Nobel Committee also thought that these two persons deserves a Nobel Prize, that too in physics. Not only that, on the same year, another Nobel Prize was awarded based on some discovery using deep learning methods, especially John Jumper, who worked for Google DeepMind. For protein structure prediction, he used deep learning methods for this protein structure prediction. So on the same year, 2024, two Nobel Prize was awarded where deep learning was partially or fully responsible for the discovery. So there is no doubt that deep learning is extremely impactful and it is influencing our day-to-day life. It is influencing the civilization. So it's undoubtedly another level of huge jump in the human civilization. And these are some of the success stories that if you think about antibiotic, which ideally does not have any connection with computer science or machine learning, even new antibiotic candidates are being found out using deep learning methods. You can see artificial chemist. Large language models have been used to perform chemical experiments. And one of the first chemical composition that was designed using LLM models was paracetamol. LLM was responsible for controlling the entire experiment, and with that kind of control, paracetamol was produced in the lab. And the scientists describe it as an eureka moment, no doubt about that. ChatGPT, everybody knows how useful ChatGPT has become. Whether it has become useful always or it has become nuisance sometimes, that is a matter of debate. But there is no doubt that it has changed how we look at the current world. ChatGPT and many other LLM engines can do miracle. It's no less than a miracle what these models can do. And on the right side, what you can see is 2 cents from our lab. We took some X-ray images, which is of extremely low resolution, as you can see on the left, and we used deep generative models to synthesize an X-ray image with significantly higher resolution, as you can see in the right side. Of course, this type of approaches may be helpful for the clinicians to make a better and faster diagnosis from different types of medical images. We are going to talk a little bit about this towards the end of this lecture. But for the time being, let us look into why we should talk about deep learning in the first place. Deep learning is useful for many different types of tasks, including classification, regression, detection, segmentation, translation, feature extraction, and most importantly, generation, and you name it. You name the task, and researchers do have a deep learning model to solve your problem. These days, the situation is like that. But it is not just the success story. There are still several issues that the researchers faced, and research is happening at a very high pace to look into this type of problems. One of the problem of deep learning method is explainability. Although we get success, we always don't know why these deep learning methods are being successful in doing this task. A good performance is not only judged by the success, but also how much explainable that success is. So explainability is undoubtedly a very significant matter that should be looked into when we are using these deep learning models for our day-to-day tasks. For example, if a doctor or a clinician uses deep learning model to make diagnosis, it's not just the diagnosis that matters, it also matters how to reach that diagnosis. Deep learning should be able to provide those reasoning. At the early days of deep learning, explainability was a very, very major issue. Many researchers explained deep learning models as black boxes. However, many researchers are ongoing, which is putting some light onto the explainability of deep learning models. And recently, over the last few years, we are seeing some explainable models coming up, which is making deep learning models more and more acceptable to the community. The second issue is generalizability. Generalizability means that while my model is useful for some X data set, when I try to use that model for some Y data set, it should show similar type of performances. I mean, if I buy a TV which works in my house or which works in the lab, but when you buy it, it does not work in your house, you will definitely not be interested to buy that TV, right? So it should be working in different conditions. It should be equally useful in different conditions. So that is the question of generalizability. If my deep learning model is useful for one data set, it should be useful for the other similar data sets also. But that is often not observed with many deep learning models. So that is the issue of the generalizability, and researchers are trying to come up with different strategies to improve the generalizability of the deep learning models. The third bottleneck in deep learning approach is computational requirements. Typically, we need high-end GPUs to run deep learning methods. So it comes with a high computational requirement, and deploying it to edge devices, deploying it to, let's say a clinic with not so high-end computers becomes challenging. And the fourth one is data requirement. Typically, I mean, we say it with all machine learning models that if you have more data, your machine learning model is likely to be better, right? And deep learning models are no exception. Especially for deep learning models, the data requirement is super high. When it comes to most modern generative models, these data requirements is like tremendous. So getting so much of annotated data becomes a challenge. Even unannotated data in a large volume becomes a challenge. But over last around 17, 18 years, different research groups, different organizations have released high quality, large scale data sets, which has made it possible to design deep learning models useful for different applications. So these are the challenges, but researchers are actively looking into these challenges to get rid of these problems and making deep learning models more and more useful. And the question, one of the questions, why deep learning models have been so much so much successful, while it is there in the literature or in the scientific community for such a long time, 70, 80 years. Several reasons are there. One of the reasons is availability of the hardware. The GPUs have become available and at a reasonable price. I mean, I would say reasonable price because 20 years back, the cost of the GPUs was way higher than what it is right now. And it was kind of unaffordable. Such large scale GPUs were not available. And even if they were available, they were of so much huge cost that it was unaffordable. Now the cost has reduced. It's not just about the GPUs, any computational hardware, the cost of that reduces over a period of time. GPUs are no such exceptions. Many different outstanding hardware technologies have been designed, which has made the GPUs faster and cheaper. The other one is storage. Computational storage has become cheaper, and 20 years back, 1 GB was a dream. Now 1 TB everybody has. Probably tomorrow your mobile phone will have 1 TB storage. So storage has enabled storage of large scale data sets, which has in turn enabled deep learning models to utilize those data sets and train it efficiently. And then we have cloud services. There are so many different cloud services, including Amazon EWS, Google, everybody is providing cloud services where you can not only access storage but also run deep learning models in a cloud fashion, right? So all these hardwares have made it possible to train high-end deep learning models. The large data set, availability of the large data set, as I mentioned, that also is highly responsible for the success of deep learning methods. And we now have open source implementation platforms like PyTorch and TensorFlow, which has made the coding related to deep learning much, much easier. So all these together has brought the deep learning revolution. So we will now look into the technical aspects of deep learning with some basics of neural network. So neural network basically consists of several layers of neurons. For example, this neural network consists of three layers. One is called input layer, the middle one is called hidden layer, the last one is called output layer. So usually neural networks have got an input layer, an output layer, and several hidden layers. I have shown one hidden layer, but there may be several hidden layers. And each block within the layer is called a neuron. Each of these circles within the layer is called a neuron. The neurons typically in a fully connected neural network, the neuron of one layer is connected to the neurons of the previous layers. With all the neurons of the previous layers, as you can see, for example, this neuron is connected to this one, and this one. And then the last layer's neurons are connected to the neurons of the previous layer and so on. There are exceptions to this, but this is the typical architecture. This is loosely inspired by the neurons, biological neurons, as we might be aware that our entire nervous system consists of neurons, which has got a cell body and dendrites and axon. So the dendrites capture signal from the previous nerve cell, then takes it to the cell body where the signal is processed and then sent through this axon to the next set of neurons. This is how information propagates through the nervous system. And in the neural network also, information propagates from the input layer to the next layer to the next layer and so on. So this is loosely inspired by the biological neurons. Now let us see what happens inside the neuron. So in a word, if I have to say what happens inside a neuron, I would say neuron is nothing but an adder, a summing unit, right? So what happens if this one is a neuron? I have a signal x1, I have another signal x2, I have another signal x3. What this neuron does, this neuron basically sums up these signals in a weighted manner. So the output from the neuron is W1x1, W2x2, W3x3, where W1, W2, and W3 are the weights corresponding to the input signals. And as you can see that inherently this neuron performs a linear operation on this input signals. Now, sometimes we consider this last input as 1. Instead of x3, I consider it to be constant 1. So the overall output becomes W1x1 plus W2x2 plus W3. And I call this last term as bias and the rest of the terms as weights. So these weights and bias are the parameters of the neural network. Sometimes I write the bias as B. So the output of the neuron will be indicated by y equal to W1x1 plus W2x2 plus B. So I can represent this weight as a matrix, capital W as W1, W2, X as X1, X2, because this X can also be represented as a vector or in general as a matrix. And the goal of the neuron, the neural network, is to learn the value of W and B or learn the value of the parameters so that I get the desired output Y. The value of Y should be close to my desired value. In that way, we train the neural network in such a way that the values of W and B are such that the output of the neuron is close to my desired value. So if my first input sample is x inside bracket 1, which has got two dimension, let's say x1, x subscript 1 and x subscript 2. The corresponding output corresponding to the first sample is given by y1 equal to w1 x11 plus w2 x21 plus b. I can represent it as w transpose x plus b. Similarly, if my second input is x2 corresponding to the second input sample, is x2 and it has got two dimension x12 and x22, the corresponding output is indicated by y2 equal to w transpose x2 plus b. So for the nth input, the output is given by this equation. And in general, if I have n number of input samples where each sample is, let's say, two-dimensional sample, so I represent the entire data set. I have n number of input samples. These are the number of samples, x1, x2 up to xn, and each sample has got two dimension as x subscript 1 and x subscript 2. I will represent my input like this. And let's say the corresponding actual observation, the desired observation, the desired value of the output is given by YO, which is nothing but YO1, YO2 up to YON. YO1 is the desired output corresponding to the first input, YO2 is the desired output corresponding to the second input, and so on. Now, when I apply this input data X to my neuron, the output from the neural network becomes capital Y equal to Y1, Y2 up to Yn. So, Y1 is the output from the neural network corresponding to the first input, Y2 is the output of the neural network corresponding to the second input, and so on. So I can represent the output from the neural network as W1 in terms of the weights and the biases. This is the first output, which is nothing but YO1. This is the second output, and so on. Question is, how can you find out the value of the weights W1, W2 and the bias B analytically so that your output from the neural network matches with the desired output YO? One of the ways is to find, W1, W2 and B such that the output from the neural network minus the desired output square, the difference between these two output is minimized. So if you can minimize this, if you can find out a mathematical formulation that minimizes this, the corresponding values of W1, W2 and B will be your desired weights and the bias, the parameters, right? But in a moment, we will see that this is very challenging. But before that, let us see what this neural network can do. It can, let's say I have a two-class classification problem where I want to classify dogs and elephants based on their height and weight. Let's say these are dog samples and these are elephant samples. So the neural network, the linear neural network that we have seen so far can actually draw a line, a linear boundary between these two classes. So it can do a linear classification. It can also do a linear regression. So if my data is linearly separable for classification or if my data is linear for regression, then this neural network that we have seen so far can be useful. So often we denote these different classes by class number. Let's say elephant has got a class number 1, dog has got a class number 2. Let us assign this class number. We sometimes use one-hot encoding to represent the classes. For example, class number 1 will be encoded as 10, class number 2 will be encoded as 01. In that way, if I have three classes, first class will be encoded as 100, second class will be encoded as 010, third class will be encoded as 001. This is called one-hot encoding, and it is extremely useful for neural network based tasks. All right. So if you see, as I said, that the output of the neural network that we have discussed so far, the output is a linear combination of the inputs. So the output, predicted output, if I have two output nodes in my neural network, the predicted output by the first node is a linear combination of the input alpha 1 x1 plus alpha 2 x2 plus alpha 3. Similarly, the second output is also a linear combination of the input, but a different linear combination, maybe beta 1 x1 plus beta 2 x2 plus beta 3. Now, if I use one hot encoding, these output ideally should be 0 or 1 because every class will be represented by a combination of 0, 1. Let's say when I talk about class 1, y1 should be 1, y2 should be 0. When I talk about class 2, y1 should be 0, y2 should be 1. So every output ideally, y1 and y2, ideally they should be equal to 1 or 0. But as it is a linear combination, you can see y1 is a linear combination of x1, x2 and y2 is also the same. There is no guarantee that y1 will be either 0 or 1 and y2 will be either 0 or 1. There is no guarantee for this, right? So what we do is we do a softmax operation. We consider this y1 and y2 and then we calculate a softmax output. It's kind of a probability value. So softmax for 1. So corresponding to y1 I have a softmax value O1. Corresponding to y2 I have a softmax value O2. So O1 is nothing but exponential of y1 divided by exponential of y1 plus exponential of y2. Similarly, O2, which is exponential of y2 divided by the same term, right? So if you see this, O1 and O2 is nothing but a value between 0 and 1. So this O1 and O2 produces um, a value in the range of 0 and 1. Let's say O1 is 0.7 and O2 is 0.3. Okay. So I can consider whichever is out of these two values, whichever is the closest to 1, I can consider that value to be equal to 1 and all the other values to be equal to 0. In that way, I can achieve one hot encoding, or I can use these numbers as the predicted class probabilities. I would say that my neural network has predicted 0.7 class probability for class 1 and 0.3 probability for class 2. In different ways, I can use this neural network, the softmax output, as the for my class level prediction. And when I use it for classification, whichever output is predicted with the highest probability, whichever class is predicted with the highest probability, that is considered to be the predicted class by my neural network. But life may not be so simple. Always the classification problem may not be linear. I may have non-linear classification problem. For example, if class 1 is like this and class 2 is like this, I cannot separate these two classes with a straight line or a linear boundary. I need to have non-linear boundary. But so far the neural network or the neurons that we have discussed can deal with only linear boundaries. So what we do is we bring in a non-linearity here. So as of now, my neural network is producing this kind of output with including weights and biases. This W naught is nothing but the bias. And after that, I include a non-linearity, which produces an output of y cap from this linear output ys. So I write y cap is equal to g of ys, where g is the non-linearity. And this non-linearity is called an activation function of the neural network. Right. And there are many different activation functions. I can have sigmoid activation function. If my output is ys, linear output is ys, sigmoid of ys is given by 1 divided by 1 plus exponential of minus ys. That's how the nonlinearity is introduced in the neural network. And it can be shown that the differential value of the sigmoid function is also a function of sigmoid. We also have tan H activation function, which looks like this. And we have ReLU activation function, which is piecewise a linear model and is very popular. And we have leaky ReLU activation function also. So the ReLU activation function basically squashes all the negative inputs and make the output equals to 0. For all the positive inputs, the output y is equal to x, equal to the input. So because all the negative inputs are squashed, sometimes leaky ReLU is preferred compared to ReLU. Leaky ReLU is a slight variation of ReLU where for the positive part y is equal to x. For the negative part, it is mx. Y is equal to mx, where m is a small number. So how to measure the performance of this neural network? For that, we actually calculate the difference between the output and the desired value, or the output and the reality or the observation. So this difference is often termed as the loss. And we have, for regression problem, we have mean squared error, which is nothing but the squared differences between the actual output and the predicted output. We take the square of the difference and divide it by the total number of training data. That gives me mean squared error. However, mean squared error is sensitive to outliers. So if I have all these data points, and if these are my actual observations, and this black line is my predicted line, with respect to all these data points, the mean squared error is small. But if I have a couple of data points which lie far away from these other data points, which are called outlier, the mean squared error becomes very, very high, which gives an incorrect impression about the accuracy of my model. So this is the problem of outlier with which mean squared error suffers. For classification, we have something called a cross entropy loss. Let's say my actual level, class level of the data is YO1 and YO2, and the predicted class probability by my neural network is P1, P2. Then the total loss, the cross entropy loss, is given by negative summation of YOI log of Pi, I running from 1 to C, where C is the number of the class levels. So basically, if you see whichever loss function we consider, the cross entropy loss or the mean squared error, it depends on the output of the neural network, of course, with the different, because we are measuring the difference of the output with respect to the actual value. Now, where as soon as the output is involved, the output is in turn dependent on the parameters of the neural network, the weights and the biases of the neural network. As a result, we can say that the loss computed by the neural network is a function of the neural network parameters, weights and biases. So, what we try in the training of the neural network, we try to minimize this loss. I mean, minimizing the loss ensures that the output from the neural network gets closer and closer to the desired output, right? So we try to find out the parameters of the neural network which would end up minimizing the loss. That means which would end up producing an output which is close to the desired output. So basically, if I consider W to be the parameters of the neural network, we want to find out such a W star such that the loss is minimized. All right. So before I move further, I'd just give a pause, and I'd request anybody, if you have any questions, please go ahead. All right. So we will quickly see how to minimize the loss. There are many different strategies for that, but we'll see the simplest one. Let's say I have two parameters, W0 and W1, and with respect to that, I have computed a loss and plotted it. So this loss is a function of W0 and W1, right? And I want to minimize this loss. Basically, what I want to achieve is let's assume that I start from this point. So I want to get to the minima of this plot. Okay. Minimization of the loss means getting to the minima of this plot. And I want to reach the global minima. Right. So question is how to reach the global minima. For that, we'll take a 2D example and try to see how to reach the global minima. Suppose I have only one parameter, W, in my neural network. Hypothetically, just consider. And the corresponding loss is given by LW. So how do I reach the global minima? Suppose I am at this point, the point of the smiley. And as you can see, this is the global minima. Now, if I ask you the question, which direction should I move, right or left, to reach the global minima? Of course, your answer will be right. And how do I know? Because by moving to the right, the value of the loss is reducing, right? So when I move to right, the derivative value del L del W is less than 0 because the loss is reducing. So if I am at this position, how would I move to the right? If I use this equation, uh, W equal to W minus eta into del L del W. What will happen? Let's consider eta to be a positive constant. Now, since del L del W is negative, eta into del L del W is also negative. So, this term gets added, this entire term gets added with W. So, initially W was somewhere here and something now gets added. Let's call it delta W. So overall, this smiley moves to the right side. That means if I use this equation, I will move closer to the minima. I'm not guaranteeing a local or global minima, but at least I can guarantee that if I use this equation at this particular situation, I will move closer and closer to the minima. Now suppose I am at this position. Let's call this position as W2. Which direction should I move if I have to get to the minima? Of course, I have to move to left, right? When I move to left, what happens? So del L del W, when I move to left, that means moving to right, that means changing the value of W actually increases the value of loss. So del L del W is greater than 0. Now, if I use this equation again, W equal to W minus eta into del L del W, what happens? This is, let's say this is W2. The new position, call it W3, equal to W2 minus eta into del L del W. Now del L del W is greater than 0. So eta into del L del W is greater than 0. So I subtract something from W2. That means subtracting something from W2 means you move to the left. That means you get closer and closer to the minimum. So I can conclude that if I use this equation to update my parameter at any point in time, if I take the derivative of the loss function, if I take the gradient of the loss and use this equation, W equal to W minus eta into del L del W, I'm guaranteed to move closer and closer to the minima. It may be a local minima, it may be a global minima, but at least I'm guaranteed to move closer and closer to the minimum. So this particular approach is called gradient descent. It's a very popular approach in different format. It's a very popular approach. And most of the approaches, as far as I have seen, most of the optimization approaches or most of the minimization approaches for the loss are dependent in one way or the other, dependent on this gradient descent approach. So the algorithm for the gradient descent approach looks like this. You initialize the parameters and you compute the gradient. You consider all the data points. For each of the data point, you calculate the loss, sum up all the losses, take the derivative, to calculate the gradient, and then update the parameters using this equation. Right? This is called gradient descent. So what happens when I actually use it for a neural network? Let's assume that I have a simple neural network where my inputs are x1 and x2 coming through these nodes with these sets of weights and biases. So what happens? Suppose I want to calculate, I want to update the parameter W5. So the equation for updating W5 would be W5 equal to W5 minus eta into del L del W5. So you can directly calculate this derivative del L del W5. Subtract it from W5, multiplying by it, multiplying this derivative with eta, subtract it from W5, and you can update the parameter. Similarly, you can update the parameter W6, straightforward. But if you want to update the parameter W1 here, what happens? W1 is given by this equation W1 equal to W1 minus eta into del L del W1. So when I try to update this parameter, I will find out that L, the loss, is not directly dependent on W1. Loss is directly dependent on this parameter and this parameter, because this is W5 and W6 are directly connected to the output Y, and loss is directly dependent on Y. So I can say L is directly dependent on W5 and W6. But W1 directly does not influence the loss. W1, W3, W2, W4, this influences the output of these intermediate nodes Z1 and Z2. They influence the overall output Y, and Y influences the loss. So I cannot directly calculate del L, del W. Directly calculating that is difficult. So what I do is I take the derivative of del L, del W. Okay. I first take the derivative of del L, del Y. So I take the derivative of the loss with respect to Y. And then what I do is I take the derivative of Y with respect to Z1, because Y is directly dependent on Z1. So I can calculate this derivative del Y del Z1, and then I calculate del Z1 del Y del W1, right? So Z1 is directly dependent on W1, so I can calculate del Z1 del W1. You see, by using the chain rule, this term is equivalent to del L del W, right? Now, if I look back, what happened? My loss was here. I calculated the derivative, the gradient, and then I calculated another gradient, and then I calculated another gradient. It looks like as if the flow of the gradient is coming from the end of the neural network to the beginning. And this particular technique, that's why, is called a back propagation technique, which is nothing but using the chain rule of the gradient to calculate the derivative or calculate the gradient del L del W1 or del L whatever parameter you want to update, and then based on that you eventually update the parameters. So similarly you can update all the other parameters as well, and as you can see that the loss function, the loss del L del Y I have to calculate, so the loss has to be differentiable. Y is differentiated with respect to Z1. So the output Y has to be differentiable. Similarly, the output Z1 has to be differentiable because I'm calculating del Z1, del W1. So every output from any node of the neural network has to be differentiable. And that's why, because the outputs of the nodes are dependent on the activation functions as well, the activation functions also need to be differentiable. So in a neural network, to enable backpropagation, every component or every mathematical operation that you perform within the neural network has to be differentiable. There are some exceptions to this, but we do engineering approximation in such cases. So in order to optimize this loss, there are several challenges. I'm not getting into that challenge part. I'm directly going to the an interesting aspect, that why are we so much bothered about the neural network? What is so special about neural network? The special thing about the neural network is called universal approximations theorem. So loosely speaking, I'm not quoting the exact terminology right now, but loosely speaking, we can say that a neural network, even with a single layer, can approximate any function. This can be proved. This is called universal approximation theorem. Universal approximation theorem says that a neural network, even with a single layer, can approximate any function. Now, what is the utility of the function? When I'm talking about two-class classification, let's say like this, I am talking about a straight line, which is a boundary between these two classes. So this is nothing but a function, a straight line. When I'm talking about this kind of classification, let's say one class here and the other class here, this can be classified using a circular boundary. This is nothing but a function. So any such function can be approximated using neural network even with a single layer, right? And that's where the beauty of the neural network lies. It can approximate any function with arbitrary precision. And then, so then the question is why, if one layer of the neural network is sufficient, why do we talk about deep networks? The reason is that the universal approximation theorem says that this is the statement at the end. A feed-forward neural network with a linear output layer and at least one hidden layer with any squashing activation function can approximate any Borel measurable function from one finite dimensional space to another with any desired non-zero amount of error, provided that the network is given enough hidden units. That means if I want to approximate any function with a single hidden layer neural network, I may need to have sufficient number of neurons. So probably the neural network will become too much wide. And such a wide neural network is very difficult to handle. That's why rather than going for a single layer neural network, we go for deep neural network. The width of the neural network, we somehow try to uh, compensate for that by having a deeper neural network. That's why deep neural network has come into the picture and has been so much successful. So this is the basics about the neural networks, and then we have convolutional neural network which can operate on the images. So if I consider an image, let's say a color image consists of three different channels, as you know, red, green, and blue. So what happens, an image is nothing but a 2D or 3D array of pixels, where if I consider a color image, it's a 3D array of pixels. If I consider a grayscale image, it's a 2D array of pixels. And this is the, let's say this is a simple image. So the problem is, if I want to pass this image to a fully connected neural network, a neural network that we have seen so far, what will happen? The spatial context will be lost. For example, the pixel 138 will go here. Maybe I have to flatten this image first before I apply it to the neural network. So pixel 138 will go here. Pixel 182 will go here. 211 will go here. And 79 will go here. So this pixel 79 and 138 will not have any uh, neighboring property which was actually there in the image. They were neighbor pixels, right? So that neighboring property will be lost if I flatten these images. So the spatial context in the image will be lost. And when I have a fully connected neural network, every neuron of the previous layer is connected to every neuron of the next layer. As a result of that, there are too many parameters. When you try to optimize too many parameters, the computational requirement becomes too huge. That's why researchers thought of something like this. They used cross correlation property. Actually, they use the cross correlation property. Suppose I have an image I and I have a kernel K, and the pixel positions in the image and the kernel are indicated by I and J. The cross correlation is given by Sij equal to I of I plus m, j plus n into k of mn, which is nothing but, let's call this as my kernel K and let's call this as my image. So what am I basically doing is I am putting this kernel onto this image at the left top position and then term by term multiplying the kernel entry with the corresponding pixel entry, right? And summing them up and replacing the center pixel of the kernel of or of that particular image region with this summed value. And we are calling it convolution. I'm pretty sure many of you come from the signal processing background, so you definitely won't want to call it convolution. But in the neural network literature, this particular cross correlation has been termed as convolution, and the community has accepted it. So these are called convolutional neural network. So what essentially happens is, if my convolutional kernel looks like this is my K and this is my image. what will happen is W1 gets multiplied with V11, W2 gets multiplied with V12. In that way, W9 gets multiplied with V33, and the center pixel of the image is replaced by this multiplied and added term. So this is the center pixel, which is replaced by this weighted addition. Weighted addition between the kernel and the corresponding pixel value. And this is called convolution operation. So when we perform this convolution operation from left top corner of the image and slide it towards right, for every center pixel, I get an output value. If I continue doing this, I will get this kind of output values, and the overall output would look something like this. On your left, there is an image, and on that image, I am operating with a convolutional kernel, which is red, and it is producing an output feature map, which is green. So my original image was 5 cross 5. I am operating on that with a 3 cross 3 convolutional kernel, which is producing an output feature map of 3 cross 3. And we say that this output feature map contains some visual characteristics of the input image, because operating with a kernel on an image region helps in extracting some features. So that's about the convolutional neural network. There are so many things in convolutional neural network that such a short lecture would not be sufficient for that. So I'm just restricting to this. So we apply this convolutional kernel on an image. I get a feature map, then pass it through an activation function. So far, the feature map that I have obtained by applying the convolutional kernel to the image is nothing but a linear operation. To make it non-linear, we apply some activation function and get the output feature map. I'm sorry, I just have to take a few seconds break. I'll be back in 30 seconds. Sorry, I got an urgent phone call. So this, when you have a 3-channel RGB image, you operate on that with a kernel of same size, 3-channel kernel, and you get a feature map, you apply an activation function, get the output. So you can apply multiple such kernels. So this is my input image, let's say. I apply a filter. Sometimes it is called a filter also. You can call it filter or kernel. So I operate this with this kernel and get this feature map. Then I operate on this image with a second filter and I get this feature map. I concatenate these feature maps, add a bias, pass it through a ReLU activation function or any other activation function, and eventually get the overall output feature map. This entire thing is called a convolutional layer. Many such convolutional layers, when they are put together, they construct a convolutional neural network. Right. So there is a concept of receptive field, but due to the constraint of time, I'm not going into that. There is an operation called pooling, which extract meaningful information from the convolutional feature map to make it smaller. But I am now interested to talk about a bit of applications of these convolutional neural networks and other type of neural network models on medical image analysis and synthesis. So next few minutes, we are going to talk about some applications. If you have any questions, please go ahead. Right.
Please, sir, Can you explain me what do you mean by squashing activation?
Acha, squashing activation function, if you look at the shape, I'll just go back here. So if you look at the shape of the typical activation functions like this, it squashes the output here, right? I mean, it does not make the output infinite at certain points, right? If the input is not infinite, the output will never become infinite. So this squashing activation function will restrict the values of the output. It will not let it go to the infinity.
If input is not infinity, then output will be not infinity.
Yes.
Right?
Yes.
Okay. Thank you, sir. Thank you. Oh.
Hello.
Yes.
Sir, actually, how, how a beginner for machine learning and deep learning, please suggest some process to begin some for machine learning as well as deep learning. If you suggest something, then it will be helpful for me.
All right. So there are two aspects of this. One is the theoretical understanding of it, and other one is the implementation perspective of deep learning. Let's talk about deep learning for now. So from the theoretical perspective, if you want to understand deep learning, I think the books that I mentioned in the first slide, which I can share those information with you as well. Those books are excellent, actually. I mean, those are very, very definitely written for beginners. So anybody can go through those books, and the lectures that I have referred to in my first slides, those explain from the very basics also. The other thing is the practical implementation. In terms of the practical implementation, also, there are several ways that we can do it. Usually, what we do in our labs, those who are taking the deep learning course for the first time, we start with the very basic implementation of a multi-layer perceptron. And that kind of implementation, if you just search it in Google, you will see a lot of implementation of multi-layer perceptron. So what we do is we basically try to teach the students of about the different functions that are used for writing the code for a multi-layer perceptron or for any other model per se. When it comes to the practical implementation or writing the code for the neural network, you have to use abstraction. You have to use the library functions. There are so many library functions are available, especially in PyTorch and TensorFlow. PyTorch, in my personal opinion, is even more flexible. You can make changes, so many changes as per your requirement. So what we ask them to do is to understand the library functions, because when we write the code for the neural network, we write it at a higher level of abstraction. We don't get into the node level details. We get to the layer level details, and then adding a layer to the neural network, then adding some activation functions after that, getting the output from it, and then defining a loss function. All these can be done using function level things in PyTorch. And there are quite some tutorials available. There are several books available. Deep learning with PyTorch. There are several books available. Which a beginner can read. There are several tutorials available, freely available, which a beginner can see. So many tutorials are available in PyTorch itself, which anyone can see about the implementation, how to write those functions with examples. Everything is available, and one can start from that perspective. So my personal opinion is, to start deep learning based implementation, one should look into the basic perceptron, fully connected neural network with many layers, and start coding it with the help of the different functions available in PyTorch. Now, anybody can use PyTorch, for example, with Google Colab, which is freely available again, or can use Kaggle. They provide some free resources in terms of the GPU implementations as well. So you can run your code on some toy dataset and see how it works. You can look into different layers of your design. You can make different types of visualization. So all these resources are there.
Okay, sir. Thank you. And these lectures will be helpful for me actually.
Yeah, so I can share these resources with you.
Kindly, sir, also share with me. This
Yeah,
is
yeah,
most
sure.
important
We'll
for
share.
us.
Sir,
Okay. Thank you,
sir,
sir.
I'm having one question.
Mhm.
That during the machine learning, so we are doing the feature selection, then we are doing the higher order feature selection, then
Correct.
we are selecting the neural network, which neural network will be suitable by using the MAC. You told that is the mean square error, RMAC root mean square error, MAE mean absolute error,
Hmm.
as well as R squared also.
Hmm.
So there are different type of errors. So in which cases, which error calculation should be done? Is there any specific criteria?
Yes, certainly. So, very good question, actually. So, you see, when we talk about errors, we have to first look into which problem we are trying to solve. For example, if I'm trying to solve regression problem, we just go to that. When I'm trying to solve a regression problem, I want to directly find out the difference between my predicted output and the actual output, right? So mean squared error or mean absolute error can be used for this when I'm talking about regression problem. Now, if you ask me whether I should use mean squared error or mean absolute error for a regression problem, it's very difficult to answer that question. Actually, what we do is we try with different type of loss functions and get an idea which loss function will be good for us. So I keep on telling our students that a huge part of neural network is engineering. You do not have a theoretical guideline of which you are going to choose, but you need to learn from your experience. You need to learn from some systematic procedures, systematic experiments, which particular error, which particular loss function, which particular activation function you are going to choose. The same question you can ask me for activation function also, whether I should choose ReLU or Leaky ReLU or TANH. I don't have a clear answer for that. We generally learn it from our experiences. As we solve more and more problem, we get an idea. Now, the problem between the mean squared error and mean absolute error is that mean squared error suffers from significantly suffers from outliers. Mean absolute error, because I consider the absolute difference, y not I minus yi, it suffers less from the outliers. So if you think that your data set has got significant amount of outliers which can impact the performance, then you might prefer mean absolute error over mean squared error. Right. But mean absolute error is not a differentiable function. I mean, when you consider an absolute, let's say a mod x is not a differentiable function, right? Because at x equal to 0, it's not differentiable. So you need to do some engineering approximation to get the differential value of this. So there comes some approximation which may also impact your performance. So which risk are you willing to take? That becomes your engineering choice, right? Similarly, when we talk about classification, we typically tend to use cross entropy loss. It's a very popular choice for classification. Generally, in 99% cases, in one way or another, we use cross entropy loss for classification. If you have a more specialized problem, we can define loss function. We many times we define loss function in many different ways based on our domain knowledge, based on our desired output. We change the form of the loss function, but these are the basic loss functions. Did I answer your question?
Yes, sir, but in which cases RMSE and R squared is used?
As I said, I mean, for regression problems, you can use any form of mean square error or R square type of losses, right?
Okay. And sir, if any segregation will be there, suppose for dual layer neural network (DLNN) or tri-layer neural network (TLNN), so in tri-layer neural network, additional hidden layer are using. So so is there any? You told that MSC we are using for the outer side, outer weightage. So on that moment, if hidden layer will be there, is there any specific criteria? Suppose if I using the dual layer, if we are using tri-layer, on that moment any differentiation will be there. So which error should take, or which error should not be taken into the account?
Well, it does not depend so much on the structure of the neural network. Rather, as I said, it depends on the problem statement or your desired output. I mean, you can use for, let's say, we talk about a regression problem. For solving the same regression problem, you can have a neural network with 2 hidden layers. You can have a neural network with 10 hidden layers, right? It depends
Yes.
on the difficulty level of the problem, how many data sets you have, and all those things.
Yes.
I cannot say that the structure or the architecture of the neural network directly influences the loss function. I would not say that, right? Um, Rather, the loss function is more predominantly dictated by the problem at your hand and the type of data you are using.
Okay, sir. Okay. But sir, we sometimes we are using the more layer to optimize or to get the better output. So on that
Mhm.
moment, the error part will come into the account. So on that moment will not be this will use. That means the any specification, any criteria.
No, that's what I'm saying. I mean, of course, when you use more number of layers,
Yes.
you use more number of layers with the intention that I would get better output, less
Better
amount of.
output. Right. Right, sir.
But what loss function you are going to use, whether mean absolute error or mean square error, that that is not directly controlled by how many layers you are going to get, because you have no clue about what is going to be the error at the first epoch of the neural network, right? What is going to be the output at the third epoch of the neural network? You don't have out. What you want that eventually after certain number of runs, certain number of iterations, I will get a reasonably better output with a deeper network.
Yes.
But initially, what is going to be your output, that you have no control over, right? Rather, where you have control or where you have information is how your training data looks like. Does it have outlier or it does not have much outlier? So based on that, probably you can decide.
Okay. Understand, sir.
Yeah. So in summary, I can say that the loss function is directly does not dependent on the number of layers in the neural network, but it's more dependent on the problem statement at your hand and the type of the data that you are using.
Sir,
Okay, sir.
Yeah. Yeah.
sir, may I ask something?
Yes, yes, please, please.
Sir, good evening, sir. Thank you very much for sharing this very nice lecture of yours. I was wondering that the number of inputs which is there, na,
Uh-huh.
x1, x2.
Uh-huh.
So the loss function, is it getting affected by the number of input?
Of
Let's
course.
say if it depends on the number of input.
Well, it depends, of course. It depends on the number of input, but exactly how directly it depends, we cannot always comment on that. Of
And
course, if I have more number of inputs, that means I have more number of parameters, more dependencies on of the output on the input. So the loss function is going to get impacted. But whether it will be more or whether it will be less, we cannot directly comment about it.
And sir, regarding the non-linearity which is there in the
Hmm.
layer,
Hmm.
uh, is there any report of using some geometrical structure or diagram for incorporating the non-linearity? Geometry based some structure or function?
Ge- uh, well, all of these functions are in one way or the other geometry based, isn't it? I mean,
Yeah, sigmoid and those, but
sigmoid, tan H, ReLU, everything is.
geometric. No, I was wondering regarding quadratic or cubic.
So
function, or
usually those are not used.
the
The
reason for not
popular
being, so what is the reason for not using those?
No, no. I mean, I would not say there is a specific reason for it. I mean, what happens typically when something becomes successful, the research on that particular direction becomes less predominant. So when TANH and ReLU and Leaky ReLU became successful, people did not explore whether there are many other activation functions which can be equally good or better. Right. So this is kind of status quo that
Okay, sir.
is.
Sir, if the sir, if the
Hmm,
problem is like that, let's say we are trying to predict the value of magnetic flux density and age for a transformer core. So
hmm,
there, if we can incorporate the BH curve of the ferromagnetic material as
hmm,
the activation function,
hmm.
so will that be a more promising option compared to the which is being popularly used, ReLU and
I I
sigmoid?
don't have a definite answer for this because I have not given a thought on this.
No,
Um,
actually, I was thinking that since the whole thing regarding the prediction of B and H depends on the property of the ferromagnetic material, so why not use the curve which is defining the property of the ferromagnetic material as the activation function itself?
It may be useful, but I do not have a direct answer for this because I have not encountered that type of activation function yet. And from the theoretical perspective, if I have to tell, I have to think about it. So I don't have an
Is it
unfortunately
possible to
right
use,
away.
sir? Yeah, sir.
Yes, it
Can
is
you just?
possible. It is possible.
It is
Definitely
possible to
possible.
use.
Yes, it is
Uh,
possible. As long
because
as I said, as long as for a non-infinite input, your output does not become infinite, you can use that function as an activation function.
And sir, in the neural network structure, the nodes which is shown here, in
Mhm.
the first line there are three nodes, in the second there are two nodes. So
Hmm.
in this it is the number of nodes are going decreasing if we are
No,
moving
no, no,
from left to right.
not always, not
Not
always,
always.
not always. This is
It
just
can
an
also
example.
increase. It
It can
can also
increase.
increase.
It can also increase.
Okay, so that does not affect the loss function in any way. That
That
kind of
affects, of
structure.
course, that affects. That
So
affects, of
so
course.
sir, can we say that the structure of the neural network affects the loss function?
The structure of the neural network, uh,
Affects the loss function?
no, no, no. I would say the structure of the neural network affects the loss, but the choice of the loss function is not directly dependent on the structure of the neural network.
Yeah, that is correct. The choice is depending on the person who is designing that neural network.
On the data set, on the type of output that you are looking for.
And sir, how we can fill up the gap, some missing data? Let's say I have collected some data. So how do I fill the missing data or the gaps in
As a
data?
gap, filling the missing data, that's a completely different topic. It can be probably done with neural network also. But filling the missing data is a pre-processing step in data processing, right? And we use different type of techniques for that. One of the techniques is regression. So you suppose you are talking about a particular feature, let's say the weight of a person, right? And you have data of 10,000 persons and maybe 2 persons weight data is missing. So using the characteristics of 9,998 persons, you predict the values of the weights for the other 2 persons and you can fill it. That could be one approach, right? There are many other approaches, but that is not directly not part of neural network.
Okay. And sir, is there any way to identify some bad data? There can be lots of data which are not correct, or maybe erroneous,
Yes,
or some
yes,
random thing has crop in. So
yes.
how to get rid of those kind of data, bad data?
There are many different ways. Basically, it's a data filtering that you are talking of, or data cleaning that you are talking of. If there is missing features, for example, in a data, lot of missing features, you can consider that data to be not suitable for your training. You can also have a, high dimension or maybe low dimensional plot of the data, and you can try to find out which data points are lying far away from all other data points. Those are called outliers, and you can exclude those outliers from your subsequent processing. You can
For
use, suppose your data is high dimensional, you can use techniques like principal component analysis to reduce the dimension of the data, plot it, and find out those which are lying far away.
okay, so that means we will transform from say fourth dimension to one dimension or two dimension,
Two dimension,
and
yes,
then we will find out which are lying far away from the data cluster or
right,
the data set.
right.
Okay. Thank you, sir. Thanks a lot for the kind
Sir,
information.
one practical problem we are facing in the for the data sets. Basically, if we are having the 5 lakhs data set, we need to
Mhm.
train the model. We need to suppose if we are using the MATLAB, if we use the 5 lakhs data set, the MATLAB will hang or it will take 2 days, 3 days time to run the program. So on that moment, we need to trim the data set.
Right.
Suppose from the 5 lakhs to we need to trim the data set 15,000. So definitely, if we are using from 5 lakhs to 15,000 data set, so there will be huge gap between 2 points of data. So can this affect the output too much, or it can be
It
ignored? The
it will
error can
significantly.
be
I
ignored.
mean, if you reduce the data set, it is definitely going to affect the output. So it is always suggested that you use as much data as you can, right, for training your model. And I'm not sure how good MATLAB is in processing these data for neural networks, but certainly you can try in PyTorch um,
Okay.
and use a GPU enabled system. At least you can try it in Colab or Kaggle, which freely gives you some GPU. It might take some time, but probably with 5 lakh data, it will still be able to process, because we have run models with 2 lakh images in Colab or Kaggle, and it has taken a lot of time, but it has run. Hmm.
So collab is excellent because it is during if we use the coding, then we can use the Google Colab. It's an excellent platform. I used during the Python learning. However, in our engineering application, majorly we are using the MATLAB. So
No,
for that
I
purpose,
I know. So MATLAB is excellent for all the statistical machine learning models, right? You use
yes,
random forest,
yes,
support vector machine, MATLAB is excellent.
yes.
But as far as neural network is concerned, my vote will be towards Python.
Okay. So on that one, Python Google Colab is best as of now. I use actually.
Yes, Google Colab is reasonably good.
Yes, sir. Yes, sir.
All
Thank you,
right.
sir. Thank you. Very nice lecture, sir.
Yeah. Thanks. I'm happy to see your interest, all of your interest in this. Um, I don't have much time left, so I'll just quickly show you some application for next couple of minutes, and then we will stop. Um, this is an application where we used X-ray images from published scientific literature. That is, from research papers, we took some X-ray images and tried to build a deep learning model for X-ray disease identification from X-ray images. And these are the quality of the X-ray images that we extracted. Very poor quality compared to the high resolution images. And we trained something called an autoencoder with this. Autoencoder is a neural network with this kind of architecture. So a few minutes ago, you asked whether the neural network layers, number of neurons always increase or always decrease. You can see that here the neurons, number of neurons has decreased up to this point and then increased. This is called an autoencoder architecture consisting of an encoder and decoder. And with this, we have designed a technique where we have designed a customized loss function. You also had a question how to design loss function. So from this autoencoder, we get some projection of the input data. If this is my original input data, This is the feature Z, the feature extracted from the input data plotted in a lower dimensional plot for visualization. Now we have tried to make clusters of different diseases, and depending on how dense the clusters are and how far away they are from each other, we have defined certain loss function, which does not look like a mean squared error or a binary cross entropy loss. It is our own loss function, something that we have defined based on the problem statement, which tries to minimize the intra-cluster distance. So within a cluster, the points should lie close to each other, and between the cluster, the distance should be as high as possible. So by optimizing these loss functions, we have been able to train this autoencoder based architecture to classify the X-ray images, and in many cases we are getting good results. And incidentally, we trained these with very less number of images from this published scientific literature. So this is called a few shot learning method, and certainly one of the first few shot learning methods in the domain of medical image analysis that we proposed 4 or 5 years back. We have extensively worked on and we are working on improving the quality of medical images. As you can see, if you have a low resolution image like this on your left, we have been able to propose generative models, generative neural network models, which can produce this kind of high quality images. You can see the zoomed in region. This is so much blurry compared to this, which is the output of our model, which looks very similar to the actual ground truth, actual real image, right? And this paper has recently been published in one of the journals. We have used different types of techniques. These particular results have been achieved using diffusion probabilistic models, while we have used something like a multi-level information rendering MLIR to get this kind of X-ray images from this kind of input. Sorry, this is the output X-ray images from this kind of blurry input. We have also used diffusion models to remove artifacts and improve the quality of images by improving their resolution. So these are some of our recent works that we are designing with neural networks, especially generative models. And there are so many things that can be done, not only in medical images, but also in other domains. And I saw the focus of this FDPs on smart cities. There are so many things that can be done with generative models and other type of neural network models. And the outstanding potential, I would say that the outstanding potential of neural network has not yet been fully explored, and it can be utilized for many different applications, which I'm pretty sure many of you would look into. So I stop here. If you have any further questions, please go ahead. Otherwise, we can stop here.
Sir,
Yeah.
sir, one last concern is that you have told na the explainability part. That means how the neural network is giving good results. The process is not exactly known. So that explainability part, how to resolve that? What are the approach or steps which can be taken to fully understand how the neural network is bringing so good results? What is the process?
There are many different approaches that have been proposed. One of them looks into the regions of the image which is responsible for producing the desired output, right? So there have been a class of models which are called CAM, class activation map models, which looks into the image regions which are responsible for producing the output. Suppose in this image you can see a lion. You can see a lion, and your model has classified this image as a lion image. So it will identify, this CAM-based approach will identify the region where the lion is located. So that is the approach taken by class activation maps. There are many other approaches. I think it deserves a complete different session to talk about it. But this is some of the approaches.
Okay, sir. Thank you. Thanks a lot for the clarification. Thank you, sir. Thank you, sir.
All right. Let's conclude here. I would like to thank everybody for your patience. Thank you so much.
Thank you, sir. Sir. Thank you very much, sir.
Thank you very much for inviting me, and I wish grand success for your
Yes,
activity.
sir, your
Okay,
lecture
sir. Thank you.
very appreciated, sir. All are praising it. Thank you very much, sir. So much good feedback there.
Thank you so much for inviting me.
Sir,
Thank you.
one small thing, sir.
Uh-huh.
Sir, actually, we need 5 MCQ. I will send you officially, sir.
Okay,
Because
so
last day some question you have to give, sir. With answers. I will send you,
okay,
sir, through mail. Okay,
sure.
sir.
Okay,
I
okay,
send you, sir. Ask you through mail. Sir.
sure. Okay,
Thank you very much.
thank you so much.
क्वेश्चन देंगे बोले बोल मेल में सुनता नहीं यहाँ हाँ हाँ एंड कर दीजिए ओके सो बोल थैंक यू ऑल टुमारो विल मीट Thank you very much.